Are you ready to supercharge your AI workload with GPU acceleration on Kubernetes? Whether you are training a massive machine learning models or running a high-performance AI workloads, Kubernetes offers the flexibility and power you need to scale efficiently. In this video, I will walk you through the architecture of a Kubernetes setup designed for AI tasks and show you how to create a GPU-enabled pod to run your AI workloads. Before we dive into the GPU pod creation, let's take a look at the architecture flow of this setup. First, we have a user workstation. AI tasks submitted from user workstation, such as TensorFlow jobs or a PyTorch model. User interact with the Kubernetes cluster via tools like kubectl or web interfaces. Then we have a firewall that ensures security, allowing only authenticated traffic to enter the cluster. Next, we have a router or switch. This component manages network traffics, connecting the user workstation to the Kubernetes master node and the worker nodes. Then request goes to the master node. The master node acts as a brain of the cluster, handling task scheduling, workload deployment, and maintaining the state of the cluster. Then we have a worker node with the GPUs. Here's where the magic happens. These nodes are equipped with GPUs to handle the heavy lifting of AI tasks. Lastly, all the nodes can access central storage where data is stored and retrieved during the execution of the AI workloads. So why use Kubernetes for AI workloads, especially with GPUs? Kubernetes automates the scaling of machine learning models, efficiently schedules resources with GPU support, and simplifies deployment across multi-cloud environment. Of course, there is some initial complexity while setting up Kubernetes for GPU, but once done, it offers incredible scalability and flexibility. I have written a detailed blog post on how Kubernetes supercharges AI workloads, which you can find in the description below. Before we dive into creating a GPU-enabled pod, we need to make sure GPU operator is up and running. To check the GPU operator is up and running, we need to run the command kubectl get pod. We need to check the pods under the namespace called GPU-operator. As you can see, it's already deployed and managing the GPU resources in our cluster. To efficiently use GPUs with Kubernetes, we use GPU operator, which handles GPU driver installation, runtime libraries, and ensure your AI workload can take full advantage of GPU resources. If you are interested in seeing a video on how to set up a GPU operator, let me know in the comment section below. So let's move on to a creation of a GPU-enabled pod. So first, let's verify GPU availability on the node. For that, we have a command called kubectl describe node and the node name. In our case, it's GPU-node. And grep for GPU.present. And we can see that GPU.present is equal to true. Now let's create a GPU-enabled pod for AI processing. So here we have a simple YAML file, which is using a TensorFlow container that requires only one GPU for AI workloads. To specify the GPU, we can specify under the request parameter. So under the request, we can specify the nvidia.com/GPU and number to 1. So we are looking for a 1 GPU for that particular container. So let's go ahead and apply this configuration to create our GPU-enabled pod. To do that, we have a command called kubectl apply -f gpu-pod.yml. That is a manifest file. The pod got created. Let's check the status of the pod. So pod is up and running. To confirm that the pod is using the GPU, we can run the nvidia-smi command and see the GPU detail. To do that, we have a command called kubectl exec-iat and the pod name -nvidia-smi. Basically, we are running a command on the top of this container. It will give an output from that particular container. So we can see it shows the driver information and the CUDA version. Now that we have confirmed the GPU is available, you can use this pod for tasks like training machine learning models with TensorFlow or running an inference for real-time AI applications. You could also accelerate data processing using tools like Rapids for faster result. The possibilities are endless with GPU acceleration on Kubernetes. So there you have it. We have walked through the architecture, discussed the importance of GPU operator, and created a GPU-enabled pod to run AI workload on Kubernetes. GPU acceleration in Kubernetes can massively boost your AI task. It's incredibly flexible and scalable. If you found this helpful, be sure to give it a thumbs up and subscribe for more content like this. Thanks for watching. See you next time.